June 1991, Mount Pinatubo, a long dormant volcano on the island of Luzon in the Philippines, began to stir after centuries of relative quiet. Local residents noticed steam and minor earthquakes from April, but by early June, seismic swarms signaled magma rising beneath the volcano. Scientists began to monitor ash emissions and tremors closely. Evacuation plans were drafted for communities surrounding the volcano and nearby bases. By mid-June, small eruptions escalated. Volcanic ash began to fall on towns and military installations, foreshadowing a much larger event. On June 12th and 13th, small explosions produced plumes. The volcano's behavior was erratic, prompting regional emergency responses. The stage was set for a climactic event. Scientists feared a large explosive eruption as magma interacted with groundwater deep beneath the peak. Pinatubo sits on a convergent plate boundary where the Philippine Sea Plate collides with the Eurasian Plate, producing magma generation and compression. The volcano itself is a stratovolcano with a history of explosive eruptions. Volatiles and silica-rich magma increase explosivity when pressure is released. Groundwater near the summit interacted with rising magma in 1991, generating steam-driven explosions that helped fragment magma into ash. Seismologists recorded thousands of small quakes and harmonic tremor, clear evidence of magma movement and pressurization beneath the volcano. Satellite and ground monitoring detected deformations of the volcano's flank, confirming an inflating magma system in the weeks before the major eruption. Combined, these geological signals pointed to a high-risk scenario, a powerful explosive eruption capable of producing widespread ash and pyroclastic flows. On June 15, 1991, a series of powerful explosions produced a giant eruption column that reached the stratosphere and darkened skies for hundreds of kilometers. The main eruption expelled vast volumes of ash and pumice. Airborne ash blanketed towns, roads, and airfields, disrupting daily life and transportation. Pyroclastic density currents swept down volcano flanks, destroying vegetation and altering river channels, transforming the landscape in minutes. Heavy ash mixed with rain to form lahars, fast, destructive mud flows that surged down river valleys long after the eruption ended. Ash reached international flight routes, forcing dozens of aircraft to divert and grounding air travel regionally for days after the eruption. Scientists estimated the eruption's magnitude as VI6, ejecting massive volumes of material and injecting sulfur gases into the stratosphere with global consequences. Communities near Pinatubo faced immediate danger. Evacuations moved tens of thousands of people to safer ground before and after climactic blast. Clark Air Base and Subic Bay facilities suffered extensive ashfall, prompting large-scale relocations of military personnel and dependent families. The eruption and its aftermath caused more than 800 confirmed fatalities and displaced over 200,000 people across affected provinces. Survivors described night skies black with ash and roofs collapsing under heavy deposits. Lifelines like water and electricity were severed in many towns. Humanitarian response involved local agencies and international aid. Emergency shelters, food distribution, and medical services were critical in the weeks after the eruption. Economic impacts included damaged agriculture, infrastructure losses, and long-term resettlement costs for communities forced to relocate from hazardous zones. In the months and years that followed, lahars continued to reshape river systems. Sediment filled channels and created recurring flood hazards. The eruption injected aerosols into the stratosphere, contributing to a measurable, short-term global cooling of roughly half a degree Celsius. Pinatubo remains a focal point for volcanic research. Improved monitoring and timely evacuations in 1991 are credited with reducing what could have been a larger death toll. The eruption also influenced policy. Hazard zoning, early warning systems, and community preparedness programs were strengthened across the Philippines. Today, Pinatubo's caldera and the surrounding landscape tell a story of destruction and renewal, a reminder of how powerful Earth processes can be. The 1991 eruption remains a case study in science, risk management, and human resilience, lessons that continue to shape volcanic hazard response worldwide.